In Unit 2, Homework 5, we're going to be looking at the greatest common factor, which is usually abbreviated GCF. When we start talking about greatest common factor, we really should address also the idea of what a factor is. So let's go ahead and look at an expression, let's say like 4x plus 12. Now in the expression 4x plus 12, we do see that there is something in common between the 4 and the 12. In fact, I could factor out a 2. Now when we talk about a 2, basically what I'm saying is there's a 2 that's in common to both of these terms. 4x and 12 are terms. And then what I can do is I can go ahead and factor out that 2. And if I factor the 2 away from this first term, I'm left with 2x. If I factor the 2 away from the second term, I'm left with 6. Now if I want to check my work here, the only thing I would do is I'd take the 2 and I would distribute to the 2x and to the 6. So I have 2 times 2x plus 2 times 6 when I distribute. 2 times 2 is 4x. 2 times 6 is 12. And if you notice, I get right back to where we started. So I've factored this correctly. So this is a factored form. And in this case, 2 is called the common factor. Let's go ahead and look at 4x plus 12 again. Now this time, instead of just a 2, I think, oh, wait, I could pull a 4 out. I could rewrite this as 4 times x plus 4 times 3. When I factor out that common factor of a 4, in the first term I'm left with an x, and the second term I'm left with the 3. So this is my factored form. And in this factored form, I factored out the common factor of 4. Now over here, on this side, this was my factored form. And in this case, my common factor is 2. Now let's go ahead and check our work with this one as well. We'll check our work by taking the 4 and distributing it to each term. So I have 4 times x plus 4 times 3. 4x plus 12 is exactly what I started with, so I'm right back where I started. Now for both of these problems, I had a common factor. The left-hand problem, my common factor was 2. In the right-hand problem, my common factor is 4. Now if you think about it, the greatest of these between 2 and 4 is 4. So 4 is the greatest common factor, GCF, greatest common factor. It means what is the largest number that is a factor of each term. So to get started working at homework problems and seeing some of the types of problems that you'll run into while you're working, we can also introduce variables as common factors. So let's go ahead and look at x squared minus 9x. Now a lot of these I'm going to break down into a factored form and then show you how the factoring works. A lot of these you'll look at it right away and know what to do, but I'm going to show the intermediate steps. Now if we look at x squared and minus 9x, we see that there's an x that is common to both of these. There's x times x here, and there's only x times 9 here. So if we were to break this down, it would be x times x minus 9 times x. Now if you notice, the greatest number of x's that is common is just 1x. So I'm going to factor away that x from each of these, and here if I factor away the x, I'm just left with x. Over here, if I factor away from the x, I'm left with minus 9. So a lot of times, your directions for a problem like this will be factor and check by multiplying. Well, if we look at factoring and then checking by multiplying, I have one more step to go. So this right here, the x times x minus 9, is called my factored form. So this would be my answer. This is what you'd put in your solution set. Now over here, let's go ahead and check it though. Let's take this x times the quantity x minus 9. Now the way we'll do that is we'll take the x and distribute it to both terms in the binomial, and I'll be left with x times x minus x times 9. So again, that's taking x times x, here's the minus sign, x times 9. Now if we multiply this out, I get x squared minus 9x, which is exactly what we started with, so this checks. So these are the types of problems that we're going to be looking at. Now in our next problem, not only do we have a greatest common factor that is a variable, we also have a coefficient thrown in. So let's look at our next one, 8x squared plus 40x. And again, my directions here are to factor, just as they were up here, factor and check by multiplying. So, when we're talking about our greatest common factor, we kind of worked with these a little bit at the beginning of the semester when we were talking about least common multiples as well. So if our numbers get really, really large, sometimes it's hard to determine the greatest common factor, but other times it seems pretty obvious. Now when I'm looking at this factored form, 8x squared and 40, well 8 goes into 40, so I think that we would be good to rewrite this as 8 times x plus 8x times 5. Now the reason I wrote it like this, 8 times x is 8x times 5 is 40x, is I want these to be out front so I can clearly see what I need to factor out. If I factor out an 8x from my first term, I'll be left with an x. If I factor an 8x away from my second term, I'll be left with a 5. So I have 8x times the quantity x plus 5. This is my solution. This is my factored form. Now, it's a good idea to check your work, especially on a test. You don't want to get a problem like this wrong when you could just quickly check your work. So what we would do to check our work is we'd take the 8x times the quantity x plus 5, and then we take this value of 8x and we distribute it to every term in the binomial. So I end up with 8x times x plus, here's our plus sign from here, 8x times 5. So 8x times x is 8x squared. 8x times 5 is 40x. So this checks because it's originally what I started up in my problem that I was given to begin with. So this is a start on factoring out the greatest common factor. And whenever you're asked to factor, that's always the directions. Find the GCF first and then factor what's remaining. Let's go ahead and try another one as well. For our next problem, let's go ahead and look at x to the 7th plus x, or 6x to the 6th. So again, our directions are to factor and, how did we say it last time? Factor and check by multiplying. Yep, so factor and check by multiplying. So, factor and check by multiplying. Well, let's focus on the factor part first. Now, when you do these problems, I'm positive you're not going to write out 4, 5, 6, 7 x's multiplied together. But this will show you how this works. And then over here, I will have 6 x's. 1, 2, 3, 4, 5, 6. Now, if you were to keep track of the number of x's that's common, there's an x for each one, except for, looks like to me, the last one. So it looks like x to the 1, 2, 3, 4, 5, 6 is what's common. This x is left over. So when you're talking about greatest common factor, you might say, whoa, that's got to be x to the 7th because greatest implies big and 7 is bigger than 6. But really, it's the greatest number that's common to both 7 and 6. And you can see from this example that only x to the 6th is common to both. So if we were to rewrite this, this would be x to the 6th times this lone x over here, plus x to the 6th from over here times 6. So I've just kind of rewritten these. So here's my x to the 6th that's common to both, so I'd factor out an x to the 6th. Now if I factor an x to the 6th away from my first term, I'll be left with an x. If I factor an x to the 6th away from my second term, I'll be left with a plus 6. So this is my solution. This is factored form. Now remember, my directions were check by multiplying. So let's go ahead and check our answer by multiplying. So I would take x to the 6th times x plus 6, which I thought was my answer, and I would take that and distribute. I have x to the 6th times x plus x to the 6th times 6. Now this is an implied 1 here. So when I multiply like bases, I add exponents. So this would be x to the 7th plus 6x to the 6th. And this is exactly what I had up here when I started, so this answer checks. So again, take the time to check those answers. You're going to greatly benefit from that on tests and quizzes. On homeworks you get a second chance, but on a test or a quiz you get that one submission. Let's go ahead and try another one. 2x to the 6th minus 10x to the 4th. Okay, factor and check by multiplying. Okay, same directions. Now we're going to start working enough to these that we'll start to see some things that are common. Now 2 definitely goes into 10. I think that's the largest number that goes into both. So let's go ahead and first of all rewrite this as 2. Let's do x to the what? Okay, greatest common factor. Well, we just learned from our last problem that greatest does not always mean the largest number. It means the most that you can pull or factor out of both. So here I have x to the 6th. Here I have x to the 4th. The largest number that I can pull out of both is x to the 4th. And x to the 4th times x squared would give me my x to the 6th. Now I'm going to write this 2 times 5. 2 times 5 is 10. And then of course this x to the 4th. So now when I kind of regroup or rewrite this, I have this 2x to the 4th, x squared, and I want to pull everything out front that's common. So if you notice, I have this 2x to the 4th out front. That is called my greatest common factor. So we haven't written this down for previous problems, but we could say it. 2x to the 4th is the GCF, is the greatest common factor. So when I factor out that 2x to the 4th, you can see that my other remaining factor is x squared. My other remaining factor, the negative comes down, is 5. So I get 2x to the 4th times x squared minus 5. And this is my factored form. This will be the solution to this. When I'm asked to factor, this would be my answer. Now eventually we'll get to some problems where this needs further factoring. But for today we're just looking at GCF. Next step would be to check by multiplying. So I would take this 2x to the 4th times x squared minus 5, and I would distribute it. So I would distribute here and to the second term. So I have 2x to the 4th times x squared minus 2x to the 4th, and the minus sign comes from right here, times 5. 2x to the 4th x squared, when you multiply like bases, you add exponents, so I'd get x to the 6th. Negative 2 times 5 is a negative 10x to the 4th. And let's check. 2x to the 6th minus 10x to the 4th checks, so I know I have the right answer. So again, all of these you can check to see if you have the right answer, and so you really should take that time to check. Sometimes not just a binomial, but a trinomial can be factored as well. This example, 2x squared plus 2x minus 10, factor and check by multiplying. Okay, so if we look at this trinomial because it has 3 terms, you might look at these first 2 terms and think, oh, an x is common. But there's no x in this last term, so I cannot say my greatest common factor will contain an x. However, I do note that there's a 2 factor in my first term, a 2 factor in my second term, and I can also pull a 2 out of the 10 in my third term. So I'm going to rewrite this as 2x squared times the quantity x squared plus, again, that 2 that's my common factor I'll pull out, times the quantity of x. Now here, let's go ahead and factor out that 2. 2 times 5 is 10, so I'll split it up. Now you can clearly see that there's a 2 that's common and nothing else. So if I factor out that 2, I'll be left with x squared from my first term plus x from my second term, and minus 5 for my third term. Don't forget the minus sign as well. So this is our factored form. Now again, we can always check our answers by multiplying out. So let's go ahead and take this factored form that we have. The 2 is out front. So again, we're checking our answer here. We have x squared plus x minus 5. And we'll take the 2 and distribute it to the first, second, and third terms. So here I'm left with 2x squared plus 2x minus 10. Now this is exactly what we started with up here. So we have the correct solution. Okay, let's go ahead and look at another one. Again, we can use trinomials. Now in the last problem we did, there was no x that was common to every term. So there's two things that we need to check for. We need to check for constants or integers that are common, and we also need to check for variables. So again, directions, factor and check by multiplying. Now if you look at this, right away 19 and 5, they don't have any common factors. 19 and 8, 5 and 8, they don't have a common factor. So what I'm going to have to go after here are the x's. Now here I have an x to the 7th, x to the 5th, and x to the 4th. If we look at this, the greatest number of x's that I have in each term, there's not 7 x's, there's not 5, there's only 4. There's x to the 4th here, there's x to the 4th here with an x left over, and there's x to the 4th here with an x cubed left over. So I could rewrite this as 19. Let's do x to the 3rd, or sorry, x to the 4th is what we decided was our greatest common factor. X cubed minus 5x to the 4th. And then if I factor out an x to the 4th, I'm left with an x to the 1st. Remember, when you multiply like bases, you add exponents. And then of course I have x to the 4th here. And just rewriting these because that's what I like to do, I have x to the 4th times 19x cubed minus that x to the 4th again times 5x plus that x to the 4th again times 8. So you can see pretty clearly x to the 4th is what's common to each of these. If I factor the x to the 4th away from my first term, I'll have a 19x cubed remaining. If I factor this x to the 4th away from my second term, I don't just have a 5x, I have a negative 5x, so don't forget that. And x to the 4th away from the third term, I have a plus 8. Now this is my solution. This is my factored form. Okay, now we can check to see if this is right or wrong, which is just so nice to be able to do, especially on a quiz where you don't want to redo a quiz because of a silly mistake, or on an exam because an exam is worth so many points. We don't want to have any mistakes there either. So to check, we'd take x to the 4th times 19x cubed minus 5x plus 8. Now we'll take this x to the 4th and we'll distribute it to each term. Now this term I have 3, so it's called a trinomial. So I have a monomial times a trinomial. And we distribute that, I'd have an x to the 4th times 19x cubed minus x to the 4th, and again the minus sign came from right here, times 5x plus x to the 4th times 8. Okay, so now let's combine these. This would give me 19x cubed x to the 4th minus 5x x to the 4th plus 8x to the 4th. Now remember, when you multiply like bases, you add exponents, because this would be xxx times another 4 x's would give me 19x to the 7th. This is an implied one, so when I multiply like bases and I add exponents, I get 5x to the 5th plus 8x to the 4th. Now this is exactly what I had up here in my original problem, so my solution checks. So again, get in that good habit of checking your answers, because there's no reason to miss any of these because we can check our work. And if I have a mistake, then I should be able to go back and determine what else is going on there. Let's make this one a little bit more interesting. I might have not only variables, but I also might have coefficients that are common. Okay, so again, directions, multiply, no wait, sorry, our directions are to factor, and check by multiplying. Okay, kind of fell off the screen there. Okay, so now when we start looking at these examples, I see here that I have an 8 and an 8 that's common. Okay, what about 56? Does it have any factors that are 8? Yep, 7 times 8 is 56. And 16 has 8 times 2, so there's an 8 that's common here. So for this example, I think there's an 8 that's a GCF. Now what about my x's? I have 9, 8, 7, 6. The largest number of factors that is common to each of these is 8x to the 6th. So 8x to the 6th is called my greatest common factor. Now this one we're not going to show that intermediate step of splitting them up. Here, 8 times 1 is 8. So I don't have anything here that I need to put in. I could put in a 1 if I wanted. X to the 6th times what will give me x to the 9th, and that would be x to the 3rd. Okay, so multiplying out, I get 8x to the 6th, x cubed. If we want to check this, when you multiply like bases, 6 plus 3 is 9. Now for my next one, I decided I have an 8x to the 6th that I can factor out as well. So the question is, what's remaining? Well, I factored out the 8 already. I factored out 6 of the x's, so that leaves me an x squared remaining. And then to check my work, when you multiply like bases, you add exponents. 6 plus 2 is 8. Okay, moving right along, let's go ahead and pull out another 8x to the 6th. Here's my negative. 56 divided by 8 is 7. X to the 6th times what will give me x to the 7th, and that's x to the 1st, or just x. Now my last one, 8x to the 6th, in order to get from 8x to the 6th to 16x to the 6th, I just multiply by 2. 8 times 2 is 16, and the x to the 6th is already there. So 8x to the 6th is my greatest common factor. So let's go ahead and pull that out front. And when I pull that out front, when I have 8x to the 6th factored away, I'm left with x cubed plus x squared minus 7x, so I got to remember that negative is there, 7x, plus 2. So this is my factored form, and again, 8x to the 6th is my greatest common factor. Now remember that you can always check these, and hopefully you're getting in the habit of looking at that and thinking through real quick. 8x to the 6th, x cubed is 8x to the 9th. 8x to the 6th, x squared is 8x to the 8th. Okay, and following through like that. So we've checked a lot of these, and I encourage you to keep doing that, but I want to get to some more problems, so I'll leave the checking up to you. But again, every test, every quiz, every homework problem, if you get in the habit of checking them, you'll have much better results. Let's go ahead and look at an example with fractions. Now it's really nice on this problem, we are given common denominators. So this problem is a little bit easier to work than if I didn't have common denominators. So again, factor and check. Okay. Well, if we look through here, the one that I can say, I'm just going to talk about the numerator, 7, 5, 1, and 1. I don't think they have anything common other than a 1. But look at the denominators, they all have a 6. So I think my GCF here is 1/6. Now let's look at our x powers. 8, 7, 5, 4. The largest number that I can pull out of each one is that x to the 4th. So 1/6 x to the 4th. If I factor the 1/6 away from 7/6, I'm left with a 7. If I factor an x to the 4th away from x to the 8th, I'm left with an x to the 4th. Don't think of this as division, because remember, when you multiply like bases, you add exponents. 4 plus 4 is 8. Here I'll be left with a 1/6 x to the 4th out front. 1/6 times 5 is 5/6, so I have a 5x cubed. Remember, x to the 4th times x cubed, 4 plus 3 is 7. So if I factor a 1/6 away from 1/6, I'm left with 1. Whoops, I should not have written that one because my GCF here have been 4s. So let's put that 4 back in. Okay, because I want my GCFs to be the same. And I'd be left with x times x to the 4th would be x to the 5th. So I have 1/6 x to the 4th again. Now this is the trickiest thing we'll do in this lesson perhaps. What do I multiply 1/6 x to the 4th by to get 1/6 x to the 4th? A lot of people think that you factor this away and you're left with a 0, but really you're left with a 1. Because if I have a 0 here, anything times 0 is 0, and this term would not reappear in my solution. So let's go ahead and finish factoring this. 1/6 x to the 4th. If I factor out 1/6 x to the 4th from each term, I'll be left with 7x to the 4th in my first term, plus 5x cubed in my second term, plus x in my third, and don't forget this plus 1 in my fourth. It's not a 0, it's a plus 1. Now if you don't have that in here when you check your answer, I'd get the correct first term, second, third, but if this wasn't there, I'd be done and I would have dropped my fourth term. So it's really important that you think about your factored form and that 1 is included. Again, it's one of the trickier spots about this lesson. Okay, let's go ahead and look at another example. We're still factoring, so our directions here are to factor. Let's go ahead and factor x to the 7th times x plus 3 plus 7 times x plus 3. Okay. Now in all the other problems we did, there was like a 6 that was common, or a 2, or an x squared. But in this case, what's common is this entire binomial. This entire binomial is common. So I can take this, and if you want to think about rewriting that out front, if it helps you visualize that, I have an x plus 3 times x to the 7th plus x plus 3 times 7. So again, what I see that's common is the x plus 3, and I need to pull the entire binomial out front. So in this case, x plus 3 is my greatest common factor. Now if I pull the x plus 3 out from the first term, I'm left with x to the 7th in my first term. And if I pull the x plus 3 out, I'm left with a plus 7. So this is called my factored form, and this is my solution. And let's go ahead and check this one, just because it's a little bit different than the other ones have been. If I check this, I would take the x plus 3 times x to the 7th plus 7, and I would take this entire value of x plus 3 and I would distribute it to both terms. So I have x plus 3 times x to the 7th plus x plus 3 times 7. Okay, and that matches what we have up here, because remember, order doesn't matter when you multiply. 2 times 3 is the same as 3 times 2. So I can rewrite this, x to the 7th times x plus 3 plus 7 times x plus 3. And I get exactly what I started with, so this checks. So working through these, sometimes your values are not going to be a monomial or a single term that's common. It could be a binomial or perhaps even a trinomial. And getting into these a little bit more complicated problems, it's going to be really important that we can understand factoring out that binomial. Okay, let's go ahead and look at another example. Of course, factor. We're doing a lot of factoring today. We're left with 5a to the 4th times 7a plus 5 minus 9 times the quantity 7a plus 5. Okay, we have the same situation here. I don't see anything that's common other than this 7a plus 5. So 7a plus 5 is called my GCF, so I'm going to pull it out front. Now I have to have 7a plus 5 in parentheses, just like it appears here. Now if I factor 7a plus 5 away from my first term, I'm left with 5a to the fourth. And if I factor 7a plus 5 away from my second term, I'm left with minus 9. So this is called my factored form. So we've gone from monomials, single terms with numbers and variables as well to be common, and we've worked up to where we're actually factoring out binomials. Let's go ahead and look at another problem where we're factoring out a binomial as well. And now this is going to come into play similar a couple problems ago. We had that 1 at the end. Now parentheses placement is key here. It's so important. Now on this problem, I see that I have a 4a minus 5 that's common. How many 4a minus 5s do you see here? And the answer is 1. That's an implied 1. So when I factor that 4a minus 5 out front, in the first term what's remaining is a 2a cubed. In the second one you might say there's nothing there, I factored the whole thing around. No, something has to be there, otherwise when you redistribute you will not get that second term. So there's this implied minus 1 that's there. Now if we distribute, we have 4a minus 5 times 2a cubed, that's here, minus, here's my minus, 1 times 4a minus 5. Now if this minus 1 wasn't here, the only thing I'd get back when I checked my answer would be the first term. So I've got to have that minus 1 in there in order for this problem to work. So those are tricky. Make sure that you keep your eye on those. The next type of problem that we're going to look at is factoring by grouping. Now usually factoring by grouping occurs when you have 4 terms. So everything we've done up till now has had 2 terms or 3 terms. I even think one of that fraction ones that we did up above had 4 terms. Factoring by grouping works well when you have 4 terms. Now when we talk about factoring by grouping, we would be given a problem similar to this. We have 4x cubed plus 32x squared plus x plus 8. Okay, now factoring by grouping is just as it says. It says to group some terms together and don't find the greatest common factor out of all 4, just find the greatest common factor in small groups. So I'm going to do this problem 2 different ways. The first way I'm going to use that idea of factoring by grouping, and then I'm going to put this in a grid and use more of a visual approach as well. So in our first problem, I could take this as my first group. Now the GCF of my first group is 4x squared. If I factored a 4x squared away from 4x cubed, I'd be left with an x plus an 8. 4x squared times 8 is 32x squared. Now in my next group, I just have an x plus 8. And I'm going to put a 1 times x plus 8 just to help clarify this. Now if you notice, I do have a GCF here. My GCF is x plus 8. So I'd pull that x plus 8 out front. And my remaining factors then would be 4x squared plus 1. So there would be my factored form. That's my answer. Remember, you can check this as well. Now another way I like to do these problems is I like to put these in a grid, and it doesn't matter how we put them in a grid, which term goes where. This is going to work every time. So I'm just going to line these up, 4x cubed plus 32x squared plus x plus 8. Okay, so this is my grid. Now with my grid, really what I'm looking for is I'm looking for the greatest common factor in this row, let's say. So in this row between 4x cubed and x, my GCF is x. In this row, or sorry, this column, both of these are columns, in this column my GCF between 32x squared and 8 is 8. Okay, look at this, x8, x8. Now, off this first row, the GCF is a 4, And the largest number of x's that I can pull out is a squared here. And then over here, if you notice, the largest thing I can pull out is just a 1. There's no x that's common, there's no 8 that's common. So what I'm left with here then is this x plus 8 times 4x squared plus 1. So this gets me to the same answer. This is still my factored form, just another approach. And I kind of like the grid. I don't know why, it's just a nice visual. Sometimes it's hard to see this x plus 8 and this 1 over here for that example. So factoring by grouping, group just as was said, or you can kind of use this table that you fill in, and then from this table you can find your GCF in each row and column, and then you get your solutions. And we'll be using this table idea again when we're trying to factor using the AC method in a couple sections. Let's try another factoring by grouping. So factor by grouping. So factor by grouping, let's use 40x cubed minus 35x squared plus 24x minus 21. Okay, GCF. Now sometimes I have to rewrite these. You know, sometimes I don't have a GCF in a group, but usually the ones that they give us, they'll kind of give us a break and give us an easy one to work with. So in my first group here, 40 and 35, they both have a 5. The largest number of x's I can pull out of both is x squared. So I'd be left with 5x squared. 5 times 8 is 40x, and 7 times 5 is 35. Now over here, 24 and 21. Let me see. 7 times 3 is 21. 8 times 3 is 24. Yep, I think that'll work. Let's go ahead and pull out a 3. So 8x minus 7. 3 times 8x is 24x. 3 times negative 7 is negative 21. Now if you notice here, our GCF is 8x minus 7, so I could pull that out front. 8x minus 7. If I factor an 8x minus 7 away from my first term, my other term has a 5x squared remaining and a plus 3 in my second. So this is my factored form. Now it doesn't matter which order you write these in, because again, order doesn't matter when you multiply. So I could have the 5x squared plus 3 first. So this is my factored form. I also want to use my little grid example as well. For my grid example, you just write in the terms. It doesn't matter which order or which one's in the top or the bottom. And then we go ahead and check each row and column. Now you're going to have to be a little bit careful here. We need to keep in mind there is a negative sign here. We have to keep track of those. So in this first row, first column, it looks like to me I could pull out a 4. 8 times 4, 4 times 10, 8 times 3. Oh, there's an 8 that's common, so let's pull out an 8x. Over here, there's definitely a minus sign that's common, and 7 times 5 is 35, 7 times 3 is 21. Now let's look for the first row. For the first row, I think there's a 5 that's common and an x squared. And for the second row, it looks like to me there's a 3. Now you might say to yourself, well, should I pull out the plus 3 or the minus 3? Just pull out what's common. There's not two negative that are common here. So here's my 8x minus 7. Here's my 5x plus 3. 5x squared plus 3. And this is my factored form. And again, this matches exactly with our solution that we got from just the factoring by grouping without the grid. The grid just sometimes helps me keep track of things. Okay, one last problem. Factor by grouping. Now in this one, go ahead and choose the method you want to use, whether it's factoring by grouping or factor using the grid. And I'll do it both ways and we'll check our answers. I have two groups here. Greatest common factor in my first group is x squared. I'll be left with x plus 8. This is interesting. Okay, if you notice I have two negatives. So there's a negative that's common here and an 8 that's common here. If I factor out a negative 8, I'll be left with a positive x. Negative times a negative is a positive. Okay, so if I factor this negative out, I'm left with a positive x plus 8. My GCF, or my greatest common factor, then is x plus 8. And my remaining factors are x squared minus 8 when I factor out. So this is my factored form. And again, that's usually what we're looking for. Okay, let's go ahead and do my quick grid here. I'm going to do x cubed plus 8x squared minus 8x minus 64. Okay. So let's see if I can get my rows and columns straight this time. In the first column, the GCF is x. In the second column, the GCF looks like to me it's a plus 8. In the first row, the GCF is an x squared. In the second row, the GCF is a negative 8. I don't have to worry about what's remaining, I just worry about the GCFs. So I can see I have an x plus 8 and an x squared minus 8, which matches my factored form perfectly. So again, choose whichever method you like and stick with it. This grid we'll be using again when we get to the AC method. If you have any questions about this lecture, please feel free to let me know. You can shoot me an email. You can also contact anyone in the Math Assistance Center in the first floor of the library, and they'd be happy to help as well. Good luck!